ChatGPT, Bard, Midjourney, these AI tools seem almost magical, capable of understanding and generating human-like text and images. But have you ever wondered what actually makes them so incredibly powerful? The truth is, behind almost every groundbreaking AI you interact with today, there's one revolutionary invention, the transformer. Before transformers, AI struggled with understanding long sentences or complex relationships between words. Previous models, like recurrent neural networks, processed information one word at a time, like reading a book line by line and forgetting what was on the previous page. This made it hard to grasp the full context of a long paragraph. Imagine trying to understand a sentence like, "The dog, which had been chasing the cat that climbed the tall oak tree, was barking loudly." By the time the AI got to barking, it might have forgotten dog was the subject. This was called the long-range dependency problem. Then, in 2017, Google Brain researchers published a paper titled "Attention is All You Need." This paper introduced the transformer architecture, which completely changed the game. It allowed AI to look at all words in a sentence simultaneously, understanding their relationships instantly. At its heart, the transformer's power comes from something called the attention mechanism. Think of it like this: when you read a sentence, your brain doesn't just process word by word. Instead, you pay more attention to certain words that are most relevant to the current word you're focusing on. Imagine you're in a library, looking for books related to space travel. You don't read every book. Instead, you ask the librarian your query, who then checks her index cards, the keys, to find relevant books. Once found, she hands you the actual books, the values. This is a simplified way to understand attention. In a transformer, every word in a sentence generates three special signals: a query, a key, and a value. The query of one word asks how relevant it is to the keys of all other words. The more relevant, the more attention it pays. This attention is calculated as a score. For each word, its query is compared against every other word's key. This comparison results in a relevance score. A high score means pay more attention here. These scores are then used to create a weighted average of the value signals from all other words. So, if dog has a high attention score with barking, the barking word's representation will heavily incorporate information from dog. This is how context is built. But wait, if it looks at all words at once, how does it know the order of words? This is where positional encoding comes in. It's like adding a unique page number to each word, telling the transformer its exact position in the sequence, even though it's processing them in parallel. To make this even more powerful, transformers use multi-head attention. Instead of just one librarian, imagine having several librarians, each specializing in a different aspect, one for subjects, one for authors, one for publication dates. Each head learns to focus on different types of relationships between words. Transformers often come in two main parts, an encoder and a decoder. The encoder reads the input sentence, understanding its meaning using attention. The decoder then uses that understanding to generate the output, word by word, also using attention. After the attention layers, there are feed-forward networks that further process the information. And to ensure information doesn't get lost, residual connections act like express lanes, allowing information to skip layers if needed, making training much more stable. So, in essence, a transformer takes an input sentence, adds positional information, then uses multiple attention heads to identify complex relationships between all words simultaneously. This rich, contextual understanding is then refined and passed to the next stage, allowing for incredible language generation and comprehension.